Hello all, in the previous video we have seen some basic concepts in IR spectroscopy. If an electron donating group is present, then what happens? If an electron donating group presents, then the frequency will get decreased, and if there is a presence of an electron withdrawing group, then frequency will get increased. And if there is conjugation, okay, if there is a possibility of conjugation, then the frequency will get decreased. These and all we have seen, and I have given you some examples also. I have given you all the values, right? All the values for functional groups. So if you know those concepts, then it is very easy to solve the questions. And in this video we are going to see some more topics, okay, some factors that affects vibrational frequencies, okay, and in addition to that we are going to solve numerous examples, right? Okay, we are going to see a very important topic, ring size effect. Okay, this is very easy also. See here the bond angle, actually frequency is inversely proportional to ring size. Okay, frequency is inversely proportional to ring size. Here it is 7-membered ring, it is 6, it is 5-membered, 4-membered and 3-membered ring. This is a ring size is very low here, right? It is just 3-membered ring, hence it will have higher frequency, but here it is 7-membered ring and hence it will have a lesser frequency. Okay, this is the trick. Frequency is inversely proportional to ring size is a trick. But what's the concept here is, see, in this case it is 60 degree, right? 60 degree. Here it is 90 degree and the bond angle increases like this. Okay, see, actually you should have bond angle. See, carbon should have in tetrahedral, carbon should have a bond angle of 109.5 degree, right? But here it is having only 60 degree and here it is only 90 degree. Due to this there will be a very large strain, okay, in that compound. So what happens is, whenever bond angle is less, okay, actually bond angle is directly proportional to S character. Okay, S character. For example, if you have triple bond, double bond and single bond. See, if triple bond means sp, here it is sp2, here it is sp3, right? Now if it is having a sp character, then 50% S character, 50% p character, but here 33% S character and 67% p character, right? Okay, see here 33% S character and 67% P character. Here 25% S character and 75% P character. So the bond angle for this is almost 180 degree for sp hybridization. Here it is 120 degree. Here it is 109.5 degree. So whenever you have bond angle less, okay, if you have lesser bond angle, then P character will be higher. Okay, P character will be higher. Lower the bond angle, greater will be the sp character. Here the bond angle is very less for this compound, right? It will have greater P character. Okay, it will have greater P character. If here you are having greater P character means, then the S character will be higher for this carbonyl. The carbonyl will have greater S character. Okay, carbonyl will have greater S character. If it is having greater S character, I told you that S character is directly proportional to frequency. Okay, S character is directly proportional to frequency. So if carbonyl is having greater S character, then definitely this will have greater frequency. Okay, first of all I am going to repeat, you just listen. It is very simple concept. See here, bond angle is less for this compound. If bond angle is less, greater will be the P character. Okay, greater will be the P character. This is the first concept. Okay, smaller the bond angle, greater will be the bond character here. So P character is utilized here. Okay, P character will be greater here. S character will be greater for this carbonyl. Okay, carbonyl will have greater S character. Okay, then greater the S character, greater will be the frequency. Why I am saying like this? See, for example, in CH you are having sp hybridization, 50% S character, but in double bond CH2 you will have 33%, right? Where will you have higher frequency, triple bond or double bond? Obviously triple bond will have greater frequency. In that case 50% S character. But see here it is only having 33% S character in double bond. Okay, so here frequency is lesser. Okay, whenever you have S character, higher S character, that particular compound will have greater frequency. Okay, greater frequency. Hence, here the carbonyl have greater S character, hence it has higher frequency. Similarly, compared to this will have lesser S character and hence it will have lesser frequency. The same, this concept is applicable to all these compounds. Hence, this will have greater frequency and then comes this and then comes this. Okay, even if you don't understand these things, just keep this in your mind. Frequency is inversely proportional to ring size. Okay, if you know this a little concept, then it is very easy to solve the questions. Frequency is inversely proportional to ring size. Okay, so questions have been asked from this ring size. Okay, now I have given you the example as ketone, right? Now I am going to give you another example. You just predict which will have higher frequency. Here among these four, which will have higher frequency? Obviously this one, because the same concept is applicable here. Here it will have a lesser, greater strain, greater the strain. Okay, the bond angle is less. If the bond angle less means P character high. Okay, here the P character is high, the S character is high in this case. Okay, S character is high for this case, and if S character is high, then stretching frequency will be high. Okay, stretching frequency will be high. Okay, this is what a concept. Then a very important values. Okay, note these values. This is for cyclic esters. Okay, cyclic esters. Okay, these are all cyclic esters, right? So for this, you just note the value because it is very important. This question has been asked frequently in CSIR, NET and GATE. I don't know why they love this compound a lot, but a lot of questions have been asked from this. Okay, 5-membered ester has a value of 1770. You just keep this in your mind. It is very easy, and while solving the problems, it will be really helpful for you guys, because 5-membered ester will have an 1770 value. Okay, it ranges from 1765 to 1775. Okay, so many questions have been asked in CSR, NET and GATE, right? Now let us solve questions. Okay, because solving questions are very, very important for competitive exams. See here, now the how you will solve these questions, it is very simple, right? Just consider this. Okay, so in this case there are no other groups, hence oxygen will give its electrons here, right? But here in this case, it has conjugation also. Okay, it has conjugation also. So whenever you have conjugation, frequency will get decreased, right? Frequency will get decreased. But here it is somewhat higher. See, in this case, this oxygen will not donate completely its electrons towards this carbonyl group, because it will donate some electrons for this conjugation also. Okay, it will donate electrons for this also, and here, okay, only 50%, only 50% it donates its electron, but in this case it is 100%, here it is 200%. See, if these much of electrons is donated towards this carbonyl group, what will happen to the carbonyl group? It will get converted to a single bond easily, right? Single bond. Double bond is converted to a single bond. Hence, what happens to the frequency? Frequency will be decreased. Okay, frequency will be decreased. See, in this case, only 50% of the electrons are moving towards this carbonyl group, means what happens to the frequency? It is higher. Okay, it is higher in this case. It is 100%, some moderate frequency. Okay, moderate frequency. So the frequency will be higher in this case, and the frequency will be lower for this case. Okay, hence it will have higher frequency. This is the order. Okay, A is great, C is greater than B, which is greater than A. Okay, this is how you have to solve the questions, right? See here, for these two examples, you try to answer which will have higher frequency. See in example A, see all the groups are same, CH3CO, here also CH3CO, right? So you just look at the remaining groups. Here it is CH3, right? It is an electron donating group, okay, electron donating group. See here there is an electron withdrawing group. Nitro group is an electron withdrawing group, right? Hence, what will it do? It will try to pull the electron towards itself, okay? It will try to pull the electron towards itself. As a result, here the lone pair of electrons will get shifted and the electrons will be donated here, okay? Since it is an electron withdrawing group, it tries to pull the electron towards itself. As a result, the double bond will be converted like this, partial triple bond character, okay? Bond order gets increased from 2 to 3, okay? Here just we are comparing, okay, not exactly like this, we are just comparing, okay? So a partial triple bond character it will attain, okay? So what happens is from the double bond it is converting into triple bond. So bond order increases, then what happens to the stretching frequency? It will also get increased, right? Bond order increases, stretching frequency also increases, okay? Because we have told you in the previous video, Hooke's law, right? Nu is equal to 1 by 2 pi c root of k by mu, where k is nothing but our bond strength, okay? Bond strength depends upon the bond order. So if bond order increases, obviously frequency will increase. Here there is an electron withdrawing group. I have already given you the tricks, right? If electron withdrawing group is present, then frequency will increase, and if electron donating group, then frequency will decrease, okay? So hence it will have higher frequency, okay? It will have higher frequency. This is how you have to solve this question, okay? Now see the second one. Second one is also very easy, right? Because all the groups are same except this nitro group. What kind of group is nitro? It is an electron withdrawing group. So obviously electron withdrawing group is present, frequency will get increased. Hence this will have higher frequency. See, this question has been asked in CSIR and GATE, okay? I think they have asked this question many times. This is a phenyl acetate, this is paranitrophenyl acetate, okay? Phenyl acetate and paranitrophenyl acetate. Actually, I have told you that the range, okay, the range of ester will lie around 1735 to 1750 centimeter inverse, okay? 1735 to 1750 centimeter. So generally ester will have this range, but here in this case we are having electron withdrawing phenyl group, right? Electron withdrawing phenyl group. So what happens here is the range can go up to 1760, okay? 1760. In this case a nitro group is also present, so hence the value will again, it may go around 1770, okay? 1770. This question has been frequently asked in CSIR and GATE exams. Okay, this question and then that 5-member ring, the 5-membered ester. See, always remember the value of 5-membered ester, okay? 5-membered ester is 1770 centimeter inverse, okay? This is one important thing that you should keep in your mind. And the second thing is this paranitrophenyl acetate. Paranitrophenyl acetate will have a value of 1770 centimeter, okay? 1770. And phenyl acetate will also have a value of 1760, okay? Then very important thing is, see the C triple bond, okay? C triple bond CH, okay? C triple bond CH See, triple bond C will have a value of 2100 centimeter inverse, whereas for the carbon hydrogen, okay, see, triple bond C is 2100, carbon hydrogen will be 3300 centimeter inverse, okay. These are all very important values, and I don't know why these questions are repeatedly asked in CSIR and GATE exams. Okay, these three. This is a 5-membered ester, and then that para-nitrophenyl acetate and phenyl acetate, and then these triple bond, that is 1-butene. Okay, the question that has been asked frequently is 1-butene. They will given the value as 2100 and 3300. So terminal alkynes will have these values. So you can easily eliminate the other values, right? Because terminal alkyne, example is butane, right? Simple example is butane, propine. These will have a value of 2100 and 3300 centimeter. Okay. So this is the overall conclusion. If there is an electron withdrawing group, then the frequency will increase, okay. And if there is ring strain, also frequency increases. If there is S character, then frequency increases. But if there is an electron donating group or conjugation or resonance is possible, then frequency decreases. So I stop with this. In the upcoming video, we will try to solve the previous year questions that has been asked in IR spectroscopy. Okay, IR spectroscopy is a very small topic and you can easily score marks. Okay, so we will try to solve the previous year questions in the next video. Stay tuned. Thank you so much for watching.